Have you ever wondered if time travel is truly possible? A question that has sparked curiosity in the minds of many, from the young to the old, the dreamers to the scientists. Today, let's embark on a journey through space-time. As we sit here today, the young and the old, we are not just in a room, but we are in space-time, a four-dimensional framework that combines the three dimensions of space and the one dimension of time. This concept, as abstract as it may seem, is the very stage on which the dance of the universe unfolds. Now let's delve deeper. The idea of space-time is not a new one. It was introduced by a man you might have heard of, Albert Einstein. His theory of relativity revolutionized our understanding of the universe. It told us that space is not just an empty stage, but it is intertwined with time, forming a flexible fabric that bends and curves under the weight of matter and energy. Imagine you're on a trampoline with a bowling ball in the center. The weight of the bowling ball bends the surface of the trampoline, creating a curve. This is similar to how a planet like Earth bends the fabric of space-time. Einstein's theory of relativity suggests that the force we know as gravity is actually the result of this bending. Objects move along the curves created in space-time. Just like a marble would roll along the curve created by the bowling ball on the trampoline, this might sound mind-boggling, and indeed it is. But the beauty of space-time is that it's not just a concept. It's a reality that shapes the universe around us, from the motion of planets to the path of light. So space-time is the very fabric of our universe. Fascinating, isn't it? As we continue this journey, we'll delve deeper into the mysteries of the cosmos, all from the comfort of our own space-time. Stay tuned for the next chapter as we explore the possibility of time travel. Could we really travel through time like in the movies? It's a question that's intrigued humans for centuries. The idea of time travel is rooted in the realm of theoretical physics and the extraordinary mind of Albert Einstein. His theory of general relativity posits that space and time are woven together into a four-dimensional fabric known as space-time. Imagine if we could warp this fabric, creating a shortcut through space and time. This is the concept of a wormhole. Theoretical physicists suggest that these cosmic shortcuts could exist naturally in the universe, and that they could potentially offer a passage through time. However, we're yet to find any concrete evidence of their existence. Then there are black holes, these incredibly dense points in space where gravity is so strong that nothing, not even light, can escape. According to Einstein's theory, the intense gravity of a black hole can slow down time itself. So if you were to approach a black hole, time would run slower for you compared to someone far away. But before you start planning your time travel vacation, remember, a trip to a black hole is a one-way ticket. The immense gravity would stretch you into a long, thin strand of atoms in a process affectionately known as spaghettification. But what about the paradoxes, you might wonder? If you could travel back in time and prevent your grandparents from meeting, would you cease to exist? This is known as the grandfather paradox. To resolve this, some physicists proposed the concept of parallel universes or the multiverse. They suggest that each decision you make could spawn an entirely new universe, thus avoiding any paradoxes. So is time travel possible? The theories suggest it might be, but we're far from having the technology or understanding to make it a reality. We're still grappling with the fundamental nature of time itself. Is it an illusion, a human construct, or a tangible dimension that we can manipulate? Time travel might still be in the realm of science fiction, but who knows what the future holds? After all, the mysteries of the universe are waiting to be unraveled, and our understanding of the cosmos is constantly evolving. What about aliens? Are we really alone in the universe? This question has been intriguing minds for centuries. The thought of extraterrestrial life fills us with a sense of excitement and curiosity that's hard to ignore. When we ponder the sheer vastness of the cosmos, it's hard not to wonder if there's life beyond Earth. The universe is so immense, with billions upon billions of stars, each potentially hosting planets with conditions that could support life. But if that's the case, where is everyone? This is the question at the heart of the Fermi paradox. Named after the physicist Enrico Fermi, the paradox questions why, given the high probability of extraterrestrial life, we have not yet made contact. One way to estimate the number of potential civilizations in our galaxy is through the Drake equation. This mathematical formula takes into account factors like the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, and the lifespan of such civilizations. While the equation is based on many assumptions, It demonstrates that even with conservative estimates, there could be thousands of civilizations in our galaxy alone. But what about those mysterious sightings, the unidentified flying objects that some claim to be extraterrestrial visitors? While many UFO sightings can be explained by natural or human-made phenomena, there are a few that remain unexplained, adding fuel to the fire of speculation. Then there's the question of intelligent alien life. Considering the age and size of the universe, it's possible that civilizations far more advanced than ours exist. They might have mastered technologies beyond our comprehension, or perhaps they've chosen not to contact us, observing from a distance. It's also possible that we're looking in the wrong way or at the wrong time. After all, our understanding of life is based on our own experience on Earth. Life elsewhere might be radically different, existing in forms or environments we can't yet imagine. The universe is so vast and still largely unexplored, it's hard to believe we're alone. So, as we continue to explore the cosmos, we keep our minds open to the extraordinary possibility of encountering life beyond our planet. And what about black holes? What do we really know about these cosmic monsters? Well, let's dive right in. Black holes, in their most basic definition, are a region of space-time exhibiting such strong gravitational effects that nothing, not even particles and electromagnetic radiation like light, can escape from inside it. Think of it as a cosmic vacuum cleaner, if you will, sucking up everything that ventures too close. But how are they formed, you ask? They're born from the remnants of massive stars that explode as supernovae. Yes, that's right. A star, much like our own sun, could potentially become a black hole. When these stars have exhausted the nuclear fuel, they undergo a catastrophic collapse under the force of gravity. This causes a supernova, or an exploding star, which blasts part of the star into space. What's left collapses under its own gravity into a single point, which we call a singularity. Now here's where things get really interesting. You see, black holes warp and distort space-time, the fabric of the cosmos. They're like a bowling ball sitting on a trampoline, causing the surface to curve. This means they bend light and time. Yes, time itself. The closer to a black hole we get, the slower time runs. Mind-boggling, isn't it? But black holes aren't just cosmic vacuum cleaners. They're also shrouded in mystery. For instance, we're still trying to figure out what happens when you fall into one. Some theories suggest you'd be stretched out like spaghetti, while others propose the existence of entire universes inside black holes. Despite our best efforts, there's still so much we don't know about these intriguing celestial bodies. They are the ultimate unknown, the final frontier of human knowledge. But the more we learn about them, the more they reveal about the nature of our universe. Black holes are one of the universe's most tantalizing mysteries, a testament to the wonder and complexity of our universe. Where do we go from here? What does the future hold for space exploration? As we peer into the vast expanse of the cosmos, we can't help but wonder about our role in this grand tapestry. The recent advancements in technology have brought us closer than ever to the stars. We're not just talking about launching satellites or landing rovers on Mars. We're talking about venturing further, to distant galaxies, to the edges of the known universe. Interstellar travel, once a concept confined to science fiction, is now a real possibility. Imagine humans setting foot on exoplanets, exploring celestial bodies beyond our solar system. Projects like the Breakthrough Starshot aim to send tiny, light-propelled spacecraft to our nearest star system, potentially paving the way for future manned missions. But let's not get ahead of ourselves. Before we start packing our bags for Alpha Centauri, we need to consider the practical and ethical implications. Can we sustain life on another planet? And even if we could, should we? The young among us might ask, why not? Isn't it the next logical step in our evolution? And they're not wrong. But we must tread carefully, for we are not just explorers but also stewards of the universe. Colonizing other planets could provide solutions to overpopulation and resource depletion on Earth, but it could also disrupt delicate cosmic ecosystems. We must balance our thirst for discovery with our responsibility to protect and preserve. The future of space exploration is not just about reaching new frontiers. It's about understanding our place in the universe. It's about harnessing the power of science and technology for the betterment of humanity. It's about asking questions, seeking answers, and pushing the boundaries of what we know and what we can do. The universe is a vast, complex, and beautiful place. It's full of mysteries waiting to be discovered. Who knows where our curiosity will lead us next?